graph is a structure which is something like this, and nowadays a lot of people are using graph because Facebook actually started the graph search or something, and
that is different.
That is different, but like now like graph came in Facebook, so people started, oh, let's ask questions about graph.
Okay.
So people have started asking questions, and it is actually a very interesting data structure. I also so I realized before this, like before all that thing, and I had to teach graphs, so I started thinking about it. But then I started thinking there was an automated test infrastructure that I had to make. So if you think about it, any system, let's say Internet Explorer or anything like that. So when I was in Internet Explorer, what people do is the automated test infrastructure used to be HTTP:/. So we used to open Internet Explorer, navigate to a page, do some actions, and then close this. And then open a new one, do some actions, close that. That is okay. But if a user is using a system, I do not open Internet Explorer and then go to YouTube and then close it and then open another thing. I actually go from YouTube to, I don't know, CNN.com and then to some other place and then other place. So basically it's a graph, and then I go back. So if you think about it, it is a graph. And mostly in the embedded systems also, which actually never turn off, it is, everything is different states.
Yes.
So it is a state. So I'm in this state and then I can go from this state to a different state. So it is basically, most of the systems are state-based systems, and those state-based systems can actually be automated very easily by a graph.
Okay.
So the automated, if somebody asks you, okay, what is, or they are asking you, you have to make this automated infrastructure, blah, 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 how would you do that? So you can ask them the questions, okay, what does the system do? What are the requirements? What are the different states? Then you can say, oh, I can make a state mechanism, finite automata kind of thing. And then you can say that you can make that as a graph, and then you can say that it will be a graph. And then you do your graph thing. That is a different kind of approach, and that is a different kind of approach for automated systems also, like testing, automated testing and stuff like that. I have not, when I was at Microsoft, I had actually not, I had not seen graphs implemented in the automated test infrastructure. So I'm getting some water. Okay. Okay. So, what we are looking at, if you look at a graph can be directed and undirected also. Directed graph is where there is a node and then there is a direction of an edge. So A is connected to D, there is no connection from D to A. So that is a directed graph. If you have
unidirectional,
that
is a unidirectional.
Unidirectional. If you have to make, well, unidirectional, what you can do is like you can actually have an edge, and the edge has a starting and an ending. If you want to make a bidirectional, you can say make an edge from A to D and make an edge from D to A.
Or you can remove simply the arrow mark.
No, I'm talking about in software, like how you will code.
Okay,
code.
References.
Yeah. So that was there, and as I told you, like I had to make that automated infrastructure. So, and this was an embedded system, so I would have generally used a Boost library, because nowadays like C# has graph library. C++ people use Boost.
C# has a graph library?
Yeah. I started looking into it, and they have like it's a library which you can.
What is the name?
I imported that library. I can show it to you.
Okay.
I think we can.
It should be on NuGet.
Okay.
Try something. Just search for it. I actually just searched for
so
it.
we can
object library.
Can we use those? Like
Yeah, you can use that, but
in interviews.
No. I don't think because everything is implemented
Okay.
in this.
Okay.
So you just say, okay, Dijkstra's algorithm start from A, go to F, find the distance, and it will tell you the
Oh,
distance.
okay.
वो तो method है ना उसके
वो तो method है.
like listing click के
Yes,
method class है
yes. So exactly. So for that in C++ there is Boost library, but in that embedded system Boost library was not implemented. So I had to teach over here. So I thought, okay, let's just make a simple graph. So I used what Boost uses. Boost is a library, C++ library.
Okay.
A lot of people use it. It is a very commonly used library and very powerful. Lot of data sets are implemented. Okay, so I implemented a very simple graph. It can be optimized, but for interview purpose, I think this is good enough, and this will actually it's very easy to understand also. So if you look at a graph, what does a graph contain? A graph is this whole structure. This whole structure is one graph. The graph has a collection of nodes. Right? And each node has
What is?
edges.
Edges.
Yeah, edges, vertices.
Okay.
Each node. So A has a list of vertices. So graph
list of 8
has a list of nodes, and nodes have a list of edges.
right
That's the basic simple thing.
right
So what they say is make an adjacency list. So what this I am making is a adjacency list directed graph. This is a directed graph because there is a direction. Each node has an adjacency list because each node has a neighbor. So that is called an adjacency list. So I will have a list of edges which will be called as adjacency list. Okay. So first we will create a node. First we will create edges, and then we will create node, and then we will create a graph, and then we will do the breadth first search and the depth first search, and then we will go through the Bijector's algorithm, how to find that, find the shortest path. We will try to find. There's an interesting question. Shortest path people ask, but let's say if you want a scenic route, we want to find the longest path.
Okay.
That can be done too. So that is actually a more interesting question than the
Longest path, like longest path can be like you just keep on going at same place multiple
and
times.
not stopping anywhere
Or if keeping one only traversing one node only at a time.
We will first discuss the shortest, and then we will make a modification to that. So then we'll do those things, and then we'll do a tries. Hopefully,
Yeah.
Hopefully, all this thing we can finish right now. Okay. So I am writing in C++, but this is extremely simple. So you can, anybody who is just sitting over here, they can just write in C# also. It's a very easy thing.
Okay.
So, but you don't have to write it. I will send the solution. C++.
Actually, I have not got anything.
Huh?
The solution previous class.
Okay. After this class, let me know, and I'll just send.
you send anything
I'll send one linked list, I think.
Yeah. I do not write because I know I'll get.
After this class, somebody will sit with me and tell me that I need to send all these solutions. So I will do that. Okay. So I will write for everything. For arrays and string, it's okay. But for everything else, like if they're asking you a data structure, try to write a class. Because
for node
for anything, for linked list, for stacks and queues, for graphs, for trees, everything, write a class on the stack over there and write functions. That will waste your time. I mean, like that will let you get some more time, and then a person will know that you know how to write classes.
right
So that is a good thing.
and you need not to worry about to give 4 or 5 question answer in
Yes.
every interview.
Yes.
You will be hanging a only one.
Only one thing. So that will actually be a good thing. Okay. So we'll write class for edge. Class a edge. And if you look at an edge, what does it have? It has a So the node that I'm taking, I will actually identify the node with a character, right? At this point, I'm identifying the node with character. There is a potential problem in this, because in that case, like if I'm taking one character, I can go to maximum of like 128 or whatever number of characters. The graph size will be only that much. I can take as a GUID, as an identifier, so that will, yeah. So that will actually give you the identifier.
Yeah.
This point, for simplicity's sake, and we are just using a character.
Okay.
So a character, let's say A. A is an identifier. Okay. So an edge has a starting and an end. Okay. So we will write public and a private. So in the private, we will have a character C start and a character C end. Should do the start and the end. And then when A is connected to B,
So basically this private C start C end is a vertex.
is the ID of the start and ID of the end.
ID.
At this point, I'm saying A is, you have to identify
A is the ID.
A is the ID.
Okay, that is value.
That is the value
Okay.
of the starting
Okay, then.
and ending. So edge, if you look at this edge has a start and an end. So for start, I'm taking C start, and I'm taking C end. The limitation with this implementation is that I am limited to only 128 characters, because after that I don't have that many, so the graph will be maximum 128. If you want to implement a bigger one, take a GUID as an identifier,
Yeah.
then it will be a huge one. For simplicity, we are just taking a character right now. Okay, so start and end, and then there is a weight. Weight is basically how much distance or whatever.
between two
Yes.
nodes.
So we will say integer I weight or m weight.
M means,
Member.
okay.
Yeah. So that is the private section, and then how we will create an edge. So the constructor will be a edge character C start, comma character start, comma character end, and integer weight. Okay, and tilde a edge, we'll just delete the edge, and then we want to get the start and get the end at times. We'll just use these functions. So there's a function called character get start and a character get end. These two functions will just return C start and C end. So I will write the constructors. So the constructor will be a edge colon a edge character start character end and integer weight. Okay, and it's a very simple class. So we will just assign whatever the start value is to C start, end value to C end, and weight to weight. So we'll say C start is equal to start, C end is equal to end, and weight m weight is equal to weight. Okay, so far very simple, right? Yes. And then tilde edge will, like, we are not creating any like new, we are not doing a new, so tilde edge will just be blank at this point. And then character a edge colon get start will just return C start. Okay, this is simple. And similarly, character a edge colon get end will return get. That is a very simple class for the edge. We understood this much? Yes, easy enough. Okay. Grace.
You'll be sending to this.
Huh?
You'll be sending to that.
Yeah. I think I actually have this on the share.
Parallelly, I am converting to C# as well.
Yes, so you can on the fly also. This is so simple on the fly. You can just do that.
If it is complex, I have to.
Yes. Okay. So if you see a node, what does a node have? Node has an ID, which is a character, right? And I have taken integer data. I'm not using this anywhere, but let's say if they ask you to that, because a node should have an identifier and then some value, right? It is storing some value. So for that value, I'm just saying right now integer data. You can replace it with a string. You can replace it with, I don't know, a templatized structure. I don't know, whatever. But this is just a placeholder. I'm not using it in this class.
So this identifier will be unique, like.
Yes.
So we will put some mechanism to make it unique. Like
In this class, I have not put that. But if you write a GUID instead of character, do a GUID. It will be unique. So see. Okay. So I have. So it has a data, and then what does it have? It has an adjacency list. It has a list of neighbors, right? So a list